What allows us to see the beautiful nature around us, ourselves, or our loved ones? The answer is visible light. But what is light? But what is light? Light is any electromagnetic radiation in any wavelength, whether visible or not. But we'll be focusing on visible light.
Light is formed when an electron gains energy and moves up to a higher state, then drops back down. The red light represents the movement of the electron. The constant pendulating or back and forth movement of the electron causes an electromagnetic wave, which is light.
Visible light is the very narrow band of frequencies that our eyes are very sensitive to. These frequencies are within an enormous range of frequencies of the electromagnetic spectrum. Visible light that is detectable by the human eye consists of wavelengths ranging from approximately 780 nanometers down to 390 nanometers.
When passing from air into water, both the speed and the wavelength of light change. Finally, the light is observed to change directions as it crosses the boundary separating the air and water, since water is denser. This bending of the path of light is known as refraction. The visual distortion is witnessed if you look at a pencil submerged in a glass half filled with water. As you can see here, there are two mediums that light passes through: air and water. As said earlier, refraction occurs when light changes speed and direction. With this, since water is more dense than air, we can observe that the light reflecting from the pencil bends once it reaches the boundary of the air and water.
Now, why does dispersion of light happen? Now, white light is made up of all visible wavelengths, so its color can be separated, or in this case, dispersed because of this. So, when the light passes through the glass, it encounters two interfaces, one entering and the other leaving. The light slows down at the first interface, but then speeds back up at the second. When the white light is separated through a triangle prism, the white light is dispersed into color components such as red, orange, yellow, green, blue, and violet. This happens because the light waves bend when it passes through a prism. Each color has its own distinct wave frequency, so when the light bends through a prism, it splits into its distinctive wave frequencies, which are the colors.
As we look into the sky, we see the different wavelengths of light that each correspond to a specific color arrive at our eye due to the collection of droplets. And the net effect of this collection of droplets is the circular arc of Roy-Dubuque that we see across the sky.